Hello everyone, welcome to my channel. In this video we will learn about the control axis of the multiple access protocol. So in the control axis is divided into three types we know, that is reservation, polling and token passing. So now first of all we will see what is the reservation. So in the case of the control axis, the stations consult one another to find which station has the right to send. So in the case of random access, there is no such kind of discussion between the stations. Okay. But in the case of the control access protocols, each station will consult one another to find which station has right to send, and it cannot send unless it has authority by other stations. Hello everyone, welcome to my channel. In this video we will learn about the control access protocols. So in the previous videos we have seen the set of random access protocols, that is Aloha, CSMA with the collision detection and avoidance. So here we are having three types of control access protocols, that is reservation, polling and token passing. So these are the three types of protocols of the control access. So first of all we will learn about the reservation. A station needs to make a reservation before sending a data. Time here is divided into intervals. Okay, in each interval a reservation frame precedes the data frames sent in that interval. So normally if you want to travel in a train, then you will first of all reserve the seat for traveling in the train, right? So in a particular date and in the particular time, for the particular train from a station 1 to station 2, that is from source to destination, you will book the ticket. So in the similar manner, so if a station wants to transmit the data, so it will reserve the particular time interval to transmit the data. So how the time interval will be reserved means, so a reservation frame will precede the data frame sent in that interval. Okay, so in the given manner it will be filled. So here the reservation frame is preceded by the station. Okay, reservation frame is followed by the station 1. So here the station 1 is going to transmit the data in the time interval 1, and station 4 is going to transmit the data in the time interval 4, and station 3 is going to transmit the data in time interval 3. Station 1 is going to transmit in interval 4. So in this manner the station is going to book or reserve the particular time interval to transmit the data. So if there are n stations in the system, there are exactly n reservation mini slots in the reservation frame, right? So if there are n stations in the frame, so here we are having 5 stations in the frame, so then there will be 5 number of mini slots for reservation available. So it is similar to how we book a ticket for the train. Okay, so suppose if a train can carry 500 number of passengers. Let us consider 500 number of passengers can travel from source to destination. Okay, then it can allow only 500 people only to travel in the train, right? It will be having only 500 seats available for traveling in the train, right? So the 500 persons can occupy the 500 seats in the train. So similarly here, if there are n stations in the system, there are exactly n reservation mini slots in the reservation frame. Each mini slot belongs to a station. When a station needs to transmit the data frame, it makes the reservation in its own mini slot. So if a station wants to transmit the data, then it will book in its own mini slot. The stations that have made reservations can send the data frames after the reservation frame. Okay, so if it is booked already the reservation frame, then it can transmit the data. So next method is polling. In the polling method, it works only with the topologies where one device is designated as a primary station and the other device is designated as the secondary station. So in the case of the control access protocols, so there will be some master and slave relationship. So in the case of the in the case of the random access protocol, each station will be having the equal rights on the station, but here it won't work. Okay, so it will each and every here a station will act as a master and the remaining station will act as a slave. So remaining all the stations must act based on the master station. So the polling method mainly works with those topologies where one device is designated as a primary station and the other device is considered as the secondary station. So here the primary device plays the main role. So it will mainly control the link while the secondary device follows the instructions of the primary device. So here the primary device will act as master and the secondary will act as slave. The responsibility is on the primary device in order to determine which device is allowed to use the channel at a particular time. So the primary device will be having all the control over the channel. Okay, it will be having the main responsibility to transmit the data to access the channel. So therefore the primary device is always the initiator of the session. So here we can see how the polling will work. So the primary station here will send some messages here, that is select, acknowledgement, data, then poll. Okay, so first of all the primary station will send a message called poll. So poll means asking. So asking whether it is ready to receive the data or not. So first primary station will send the secondary station A that whether it is ready to receive the data or not. So it is asking the station A, and station A responds that it is not interested in transmission of the data, in receiving the data. So that's why it sends a negative acknowledgement to the primary station. Okay, so now let us see what happens here. The primary station will ask the next station, that is B. Okay, so it will ask the next station B whether it is ready to receive the data or not. So it will ask the station D. Okay, so station B is ready to transmit the data. So it will send the data and primary station will send the acknowledgement that the data is received. Okay, so this is how the transmission will be done, that is the transmission of data from B to A, primary station. Suppose here the primary station only wants to transmit data to B, then it will send a message called select to the station B whether it is ready to receive the data or not. So if it is ready to receive the data, then it will send an acknowledgement here. Okay, so it is ready to accept the data. Then the primary station will transmit the data to the station B, and it will, after a successful transmission, it will send the acknowledgement to the primary station. So in this manner the polling is done. Okay, so here main messages are polling, acknowledgements, negative acknowledgements, select and data. So this is all about the control access polling protocol. So next one is the token passing method. So in the token passing methods, all the stations are organized in the form of a logical ring. We can also say that for each station there is a predecessor and a successor. So predecessor means the neighboring nodes. Predecessor and successor is a station that is logically before the station in the ring, while the successor is the station that is after the station in the ring. The station that is accessing the channel now is the current station. So basically a special bit pattern or a small message that circulates from one station to the next station in some predefined order is commonly known as a token. So possessing the token mainly gives the station the right to access the channel and to send its data. So in token passing, when a station receives the token and has no data to send, then it just passes the token to the next station. So here we will see how the token passing will be done in the ring topology. So it will work on the different topologies, that is ring, bus and star ring topology. First we will see how it will work in the ring topology. So here each station is having the predecessor and the successor, that is before the ring, before the node and after the node. Okay, so if a station wants to transmit the data, it must first acquire the token. So token will give the priority and eligibility of the particular station to transmit the data across the topology. So here the station 1 has got the token and it is ready to transmit the data over the topology. Okay, so after acquiring the token, it will get the eligibility to transmit the data. So after transmitting the data, it will leave the token and the token will pass to the remaining any stations which are ready to acquire it. So possessing the token mainly gives the station the right to access the channel and to send its data. So after receiving the token also, if the station is not interested to transmit the data, then it will just pass the token to the next station. If it has completed the transmission, or if it is not interested to transmit the data, then it will pass the token to the next station. And here the main problem occurs while using the token passing technique is the duplication of tokens or loss of tokens. So the insertion of the new station, removal of a station also needs to be tackled for correct and reliable operation of token passing technique. So here the main problem is with the tokens, stations and the links. So if the link is broken here in the ring topology, then the transmission will be fail here, right? If any link is broken, then the transmission is failed. And if there is any loss of token or if there are any duplicate tokens also, there is a transmission failure. Okay, so the problem will occur in the token passing technique. Suppose if you are adding some new nodes to the network, or if you are deleting some nodes from the network also, then the problem will arise in the token passing technique. So these are some of the problems in the token passing technique. So similar to the ring topology, you can use the dual ring topology, that is a bidirectional connection here, okay, between the stations, and we can apply this same token passing technique for the bus ring topology. So here each and every node are connected to a backbone network called a bus, and each station which is having a token will be having the predecessor and the successor. Similarly, it will work on the star ring topology also. So here the hub will act as the main connecting node. Okay, so if node 4 wants to transfer the data, then it will acquire the token and it will transmit the message to the hub and then to the destination, that is 2. Okay, so if it wants to transmit the data, it must first send it to the hub and then to the remaining stations it can transmit the data. And in the bus ring topology, the transmission is done through the backbone network. So this is all about the token passing techniques in the controlled access. So these are this is all about the controlled access, that is token passing technique, polling and the reservation system. Thanks for watching my video.